Thank you, everyone. Welcome to Go Beast Mode with real-time reactive interfaces in Angular and Firebase. So speaking of beast mode, I have two small children, a 5-year-old and a 2-year-old. And getting them to go anywhere is like trying to perform a miracle. So the first challenge is getting all their stuff together so that we can leave. The 2-year-old needs his Ninja Turtle, the 5-year-old needs his Legos. The 2-year-old decides that he needs the 5-year-old's Legos, and now we have a conflict over shared mutable toys. And to make things even more challenging, we still need to get them in the car. And when dealing with small children, the problem is when you tell them to go in this direction, they go this direction. And so now we're trying to get our stuff together, and we're trying to get moving in the same direction. And the only way I found to do that is by repeating myself over and over and over. And it would be so nice is when I'm leaving, all the stuff that I need is within arm's reach as we're walking out the door together on the first try. And I was feeling sorry for myself the other day, and I realized this is the same feeling I get when I'm programming sometimes. Like, I wish I had the ability to get the things that I need together into where I want it to be without having to repeat myself over and over about what I want to happen. And like children, I need to do this asynchronously. Well, parents, I'm sorry, you're out of luck, but programmers, ta-da, enter observables. So most of us have heard of observables, and I would wager that some of us have even used them at least once, or would at least admit to it. So I mastered it in about 3 minutes. To promise, boom, problem solved, right back into my comfort zone. Ben Lesh is shooting mind bullets at me right now. But honestly, observables are so much more than doing server calls in Angular 2. So much more. In fact, they give us the ability to encapsulate, transport, and transport data or transform data from user interactions to do some really cool stuff in the UI. So what I mean by that is when we have a user event, we can encapsulate that event in essentially a tunnel that serves as a highway of sorts for us to transport our data wherever we want it to go in our application. And as if this totally private superhighway wasn't cool enough, we can set up custom factories along the way to make sure that it is in exactly the shape we want when it gets to where it's going. So what this means is that when your data reaches the end of the stream, you should be able to just dump it into your application and it will work. In many cases, with an asynchronous pipe, you can bypass your component class entirely and just put it right into your template and it will render. And so how does this work? Well, it's the combination of two classic original gangster design patterns here. So we have state, which allows us to encapsulate a data object, and then we can pull values from it incrementally. And then we have the observer pattern, which allows us to communicate events, or that an event has happened to our consumers at some indeterminate time. Combine these together, and we have the ability to communicate state over time. So as new state is available, we can communicate that over time. So visually what this looks like is we have events that happen over time, and with each event, we can transform that into whatever we need until the stream is complete. Now we're familiar with this concept of values over time thanks to promises. The difference is that with a promise, we get one value. With observables, we get many values. We can thank the iterator pattern for this. Equally important is that data is pushed to our consumers as it becomes available. You can thank the observer pattern for this. And so now, I want to take a moment and address pretty much the unanimous sentiment of every developer ever. Okay, everybody don't be sad. It's true. Observables are hard, but they're not as hard as the Germans would have us to think. That was a joke for Pascal. Don't be mad. So I find that with observables, the problem is people fail to make the distinction between the observable stream and the 10,000 RxJS operators that are available. That is just overwhelming. But when you set aside the vastness of the operators, the observable stream itself is much easier to mentally reconcile. And so now we're at the challenge behind the challenge. Most people have simply not trained themselves to think in observables, or streams for that matter. So traditionally, applications work on an input-output model. So when we need data, what do? Well, we call a method, and we supply input, and we pull the output to us to do something. In the case of, for instance, DOM interactions, we bind a DOM event to a method. When that event fires, that method gets called from our component class, and we pull that event data into our class for processing. With streams, it's helpful to invert this, and so this is really critical, that we no longer are trading input for output, but rather we have an event that is already outputting data for us, and we simply need to decide where we want to input it into our application. And so this exchange of output to input makes up the basic observable sequence, or as I like to call it, the observable sandwich. So what you have is your initial output of some data, and then at the end of it, you have this final input into your application, and in the middle is just magic. In concrete terms, we have an event that outputs some data, such as a mouse click, mouse move, input, etc., and then its final input is into our application in the form of a subscribe method. And then in the middle of this delicious sandwich, we can choose what it's going to be because of the operators. So let's see this in code. So anytime I work with observables, the first thing I do is identify where is my initial outputs, where is my data coming from? And then from there, I identify where is my final input. So our initial output is in the form of this click event. And our final input is in the subscribe block. And the reason why I call it final input is because once it is in the subscribe block, it is in its final form and therefore no longer under control of the stream. Now, if you notice, this event object is the actual DOM event from the click. Not very useful. So I'm going to teach you the most fundamental, most important concept in observables and life, actually, now that I think about it. When life gives you lemons, map it to lemonade. That's it. The core of my talk right there. So we're taking this event and we're saying we don't need this. Instead, we need this ultra critical life-changing message of beast mode activated. And because these operators are pure in nature, we can stack them on top of each other until it's turtles all the way down. So in this case, if we only wanted to allow click events to go through, if the shift key was held down, we just add in a filter operator and filter out everything that does not match our filter criteria. And so behold the sweetness of our labors. So we click and we're setting the message. So invariably, the next question is, how do we preserve state in a stream? Well, you're in luck because I knew this was going to happen. I have a demo. So we have a write button, and we have a ball element. And we're binding the left and top attributes to this position object. And then we have some code. So let's work the system here. Where is our initial output? It's a click event. And our final input, well, we're just assigning the result to a local position property. So now, how are we transforming the data? So we're mapping this event to something useful. In this case, it's the number 10, as in 10 pixels. And then we're saying start with an initial position property of 100. And now for the good stuff. Using the scan operator, we are able to take the previous accumulated values and use the current value that's coming through the stream to do operations and come up with new state within the stream. So in this case, we're saying take the accumulated x and add it to the current value, which is the new x, and return a new position object with the updated x property on it. And so now, when we click it, it is nudged to the right by 10 pixels. But now the question is, we've gotten this far. We can visualize a stream from start to finish, initial output, final input. But what happens if we have more than one stream? So I'd like to make an analogy here. If you've ever had soda from a soda fountain, if not, I'll take you to McDonald's later, but in your cup, you have soda. But another way of looking at it is that you are drinking the combined streams of carbonated water and syrup. And so with that in mind, let's look at some more code. Oh, bonus concept first. It's completely acceptable and encouraged to break your initial outputs into smaller pieces so that you can compose them together later. So what I've done is I've broken out my right stream, and then I've modeled a left stream after that. The difference is one returns a -10 and one returns a +10. And then using observable.merge.sodaFountain, we're saying take the left and right stream, and when either one of these emit an event, go ahead and pass it on to the rest of the stream. So we are taking two small streams and we're combining them into one large stream, like a soda fountain. And so now we have been mapping our events to simple properties. But I lay in bed at night sometimes and I wonder, what can we put in a stream? Simple values? Could we possibly put in more complex data objects? Well, the answer is yes. I'm going to spoil it for you. But if we can communicate data in a stream, can we possibly communicate future behavior? Well, I present Exhibit A to the court. So what we have here is two streams, a left and right stream that's capturing a key down event, and we're just using the right and left arrow. So things are about to get berserker up in here when I show you what we're mapping to. So in our map2 method, which is just short for map, what are we returning? This is a function. So we are returning a function that wraps a call to either increment or decrement. That will get called sometime in the future. Well, the future is now. So if you look in your scan operator over here, the current parameter is actually the method that we returned in our map2. So then we can just take that and call it and pass in our accumulated value. And so what this looks like is now when we press the button, we can move the ball around. And in this case, I've extended it to use or modify the Y property as well, so now you can move up and down, but you could extend this behavior to infinity. So this is functional programming for the win. So all of our streams have really been kind of from output to input, straight shot. But equally valuable is the ability to use streams to start other streams so that when you can sequence them, you can start to model real-life interactions. So for instance, drag and drop. So within our code, let's break this down. We have an initial output of move, which is just grabbing the mouse move, and we're mapping it to an XY position. Then we have a downstream that is just capturing the mouse down event. So when you are doing drag and drop, how does this actually work in real life? A user presses down on the mouse and then they move it. So the first piece in the stream is going to be down. So this is going to start it, but once the down event has happened, our mouse is down, we do not care about that event. What we really care about is the move event or the move stream. So we need the ability to switch our focus from the down to the move. Well, in the switch map operator here, what is being returned? Well, move. So now the question is, what's going on in this block below? Well, the move stream. So whatever the move stream is outputting, that's now what is going into this bottom block. So essentially we're saying we now have the downstream, but switch to the move stream. And so the question is, how do we drop the ball? Literally, in this case. Well, with a mouse up event. And for this, we can tell the move string to take values until the upstream fires any event. So we're saying move take until up. The minute up fires an event, the move stream is done. And as a result, because the move stream is no longer emitting anything, the entire stream stops until somebody clicks the mouse down again, and this starts all over. So we've been using operators to transform our stream, but I would like us to think about what effect the actual origin of the stream has on the output. So I'm going to show you an example, and we're going to change one thing. So I'll show you the first iteration, and then we'll move on to the second. So what we have here is a line component that we're iterating over, and we're iterating over the lines collection, and we're adding it to the stage. Then within the line component, we have an SVG line that we're mapping the attributes to this line object that we're passing in. So this is Angular 2, 101, and now we have the code. So what we're doing is we're capturing the click event, mapping it to an XY pair. We've seen this before. This is where it gets interesting. To do a line, you need 2 points. So we're using the pairwise operator to say group our events into pairs as it comes through the stream. So it's taking, if you have 1, 2, 3, 4, 5, it's going 1, 2, 2, 3, 3, 4. And because now we have these pairs, we can map this positions array to something that our line understands. And then we're just passing it into our lines collection. Well, what do you think this looks like? Surprising no one, like a bunch of lines. I think everybody saw that coming. So now, in our initial output, I've changed one thing. And instead of a click event, we have a mouse move event to kick off the stream. Notice we have not changed any of the operators. So this is, again, the power of having functional programming with pure functions. So now we have something a lot more fluid. But by changing a single thing in our code, which is the origin, we now have 2 totally separate and viable applications in real life. I think everybody's getting a little serious here. Like, you especially look super serious right now. So I think it's time for us to have just a bit of fun. And so by fun, I mean animations, always. So anytime you hear me say fun, that means let's go do animations. So this is the most simplest animation example I could come up with. Click, we map it to an XY pair, and then we just drop it into TweenMax, which is a pretty awesome animation library. And so now, feast your eyes on this. Okay, I'm not done having fun. So let's do something else. Here's another example. This is kind of actually everything else that we've covered. We're just putting it together in a slightly new way. Mouse move, X and Y pair, and we're mapping it essentially to a circle object that we're dropping into this collection. Then we have a circle element that we're doing ng4, and we're attaching it to the stage. I may have oversold the fun part a little bit because it's just one line of code, again, TweenMax, and we're fading it out and shrinking it. But what this looks like is something like this. So a rather simple visualization, but I was able to do it in just a few lines of code, and with a bit of imagination and talent, somebody could do something even more impressive. All of our events to this point have started from a UI event. But what would happen if we could actually take that event origin and put it into a database that everybody could consume? Well, that would be like a real-time observable, man. And unlike levitation or invisibility, this is actually not as hard as it sounds. The first thing we need is a real-time database. Where are we going to get one of those? That's right, Firebase. So, ladies and gentlemen, I present to you the wizard behind the curtain. And because Firebase has the real-time databases, we need to connect. So this is about 8 lines of code, including the import. So really what it is, you just pull this config that is generated from Firebase. So this is an actual config that was generated. You drop it in, and then in your ng module, you just say Angular Fire module dot initialize app and drop in the Firebase config. Well, we're there. That's it. We're connected. So now we need to consume the real-time stream. Spoiler alert, though, this is, again, going to be almost underwhelming in how simple it is, and I think that's profound. So we simply use Angular Fire 2 to connect to a remote object at this endpoint, which fortunately for us returns an observable that we can then consume. But how do we update the real-time stream? Again, you may want to sit down for how hard this is going to be. At the end of our subscribe block, we're simply saying, hey, remote stream, update yourself with this new object. So now, all together, we have an outgoing stream and an incoming stream. So generally, when I want to take a local stream and make it a real-time stream, what I end up having to do is just split it in two, so that I have an outgoing and an incoming, and then in the subscribe block of the outgoing, I just say, hey, update this thing, and in the incoming, I just subscribe to it as if it were any other observable stream. And I think that when you look at this, this is really a small surface area for Angular Fire. So we have this, and when you look at it, just a few lines of code. I think it's time for us to have a heart-to-heart, though. I really appreciate the fact that we have a full house and everybody has taken time to come and the conference, but more importantly, come and hear this talk. And I've used this opportunity to show you, well, what appears to be a bunch of nonsensical examples. Like, how can you possibly use this to be more awesome? Well, to find out, we're going to have to go beast mode. So, it's beast mode time. We are about to have a wax-on, wax-off moment. So let's go, Karate Kids. That simple observable stream with a button, well, this is a real-time clicker, which you can use in any sports event. I've actually made money with this example for a CrossFit company. Anyways, so left and right, what could we possibly use for that? Well, you say left and right, and I say previous and next. And so now we have a real-time presentation or photo slider. And what about the drag and drop example? Well, here you can drag a pin on a map for $1 billion. If Uber did it, why can't we? And what about those lines of doom? Has anyone heard of Map My Run? I really did this run this morning, by the way. Totally kidding, not beast mode at all. But click, 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 and now we have something like Map My Run. And what about those kinder, gentler lines? Well, we have real-time document collaboration, annotation for days. Apparently, this person does not want to go beast mode. And the animating DOM manipulation, I have one word for you. Super awesome games. Pew, pew. Everybody just got their money's worth with that. Okay, so we're in like full-on beast mode right now, but depending on where you work, we may have to step it up. And so I want you guys to stop and consider that it's business mode time. So Mike Broccoli and I cooked up an example that's guaranteed to boost your bottom line. You cannot go wrong with a real-time slider. Side note, if anybody works for a financial company, have your people call my people. I'm available to show you how I did this. Yuri, really? Still? That's okay. I love you. And you. And you. Angular hugs for everyone. In all honesty, if you go to this Twitter account and you follow me, I will post all of this code shortly. I just want to make sure that it's Ben Lesh approved. But I also have a free RxJS starter course that I'm just going to release free of charge. It's almost ready. Again, just videos are hard. But you can follow me on Twitter. Keep your eyes for that. It's going to be totally free, and it's going to cover a lot of the stuff that we've done here. In the meantime, stuff that you can use right now. So if you go to Egghead, they have a ton of great stuff. Step-by-step async JavaScript with RxJS. Introduction to Reactive Programming by Andre Staltz, who is truly the beast mode. And in parting, with 6 seconds left, I have only one request of this amazing audience. That's right. I request the highest of fives. So catch me in the hall, high five. And on that note, thank you very much. You guys have been awesome. Now go build some crazy stuff, you crazy kids.